Hi everybody, welcome to this Java tutorial. Today we're just going to have a go at simulating the fetch component of the Fetch-Decode-Execute cycle, and we're going to use this little project as an opportunity to consider one-dimensional and two-dimensional arrays. Okay, so let's get started. In my main function here, I'm just going to call my starter function, which I'm just going to call it fetch. So all I'm going to do is call the fetch function. Let's design this function. It would be great if there was a library file that I could import into my project which had this function available and I could just use it. That would save me time in my project. Also, I wouldn't have to test my function because the imported library file would already be tested. That would save me time. Unfortunately, I can't find a library file which has a function that does what I want to do, so I'm going to have to design this myself. Now this function doesn't return anything. It's called fetch, and it doesn't take any parameters. Now let's think about what we want to do. We want to somehow get the instruction set of addresses that we're going to visit in RAM. Those addresses are going to be loaded into the memory address register one by one. We'll go to RAM to find those addresses, grab the data at those addresses, and then return the data to the memory data register. We'll then send that data to the control unit, and the control unit will decode the information that we got, and then the arithmetic logic unit will execute any of the instructions that we get. Okay. So once we get the instruction set, we need to loop through the instruction addresses, sending them to the memory address register. Grab the data from RAM at the address, which is stored in the memory address register, and store that data in the MDR. And then send the data in the MDR, whatever it is, it could be an instruction, to the control unit for decoding. And then finally, the ALU will execute the instruction. And this is just going to go round in a loop while we have some addresses of the next instruction to be executed. Okay. So first of all, we're just going to create a string array. I'm going to call it instruction addresses. And I'm going to call a function which will give me those addresses. So I'm going to get those into my program. In the loop, I'm going to loop through this string array, instruction addresses, we're going to visit RAM, we're going to send RAM the current address of the next instruction, and we're going to, hopefully RAM will return the data which we're going to store in the MDR. Okay, so the MDR will be sent whatever we get after we visit RAM. And when we visit RAM, we're going to send it the next instruction that needs to be executed. So we're just going to loop through this string array and just send it the next string that needs to be. Okay, so I've got a new variable here, MDR, which is a string, because this is a string array. This is a string array, so this should be a string. So let's just declare that variable up here. Now after we get the data, after we visited RAM, we found the address in RAM, we've grabbed the data, and now we've stored the data. Let's send that data to the control unit for decoding. And then we'll do something with the ALU for execute the instruction. So this is the loop that we're going to be going through. So now, I'm just going to get rid of these comments. That's the end of my fetch function at the moment. Let's design these outstanding functions. First of all, the get instruction addresses function, which seems to return a string array. Okay, public static string array get instruction addresses. There are no parameters. So what I'm going to do here, it's a bit basic, but that's fine. I'm going to create a string array. I'm going to call it addresses, and I'm just going to quickly populate it with imaginary addresses in RAM. So to signify that it's an address, I'm just going to use a hash mark. So that at address, there's something that we need to do at address 0. There's something we need to do at address 1. There's something we need to do at address 2. There's something we need to do at address 3. At address 4. And let's just finish at address 5. There could be thousands of these, but we're just going to stop there. So we're going to loop through these addresses. These are the addresses of the next instruction that needs to be executed. Okay? And this is what we're going to return to the calling program. Okie dokie. So we've satisfied that problem. Now let's move on to the next problem. We're going to visit RAM, and we're going to send RAM the current address. We're going to find the data at that address, and we're going to send that data back to be stored in the MDR. Okay? Now, MDR is a string. So this function, visit RAM, returns a string. So let's design this function. And as a parameter, well, instruction addresses is a string array. There it is. So instruction addresses I is just one string in the array. Okay, so this is a string. We're sending a string to the visit RAM function. I'm just going to call it S. Doesn't matter what you call it. Now, let's just design a two-dimensional array which will simulate RAM. And let's say there are 6 rows in this array, just to keep things pretty simple at the moment. So in these arrays, these are, we're going to have the address that we're looking for, or the address in RAM, and the instruction that exists at that address. So I'm just going to put in some dummy instructions. It's pretty meaningless, guys. Don't panic too much about this part. But we're just creating a two-dimensional array with some instructions. And these are stored in RAM. In fact, just to quicken things up, I'm just going to delete that. I'm just going to copy these. And we'll do at address 3 there's something, at address 4 there's something, at address 5. These are all the addresses in RAM, and these are all the contents of those addresses. So what this is really saying is, when we visit address 0, there's an instruction there which says load anything that you find at address 54. The next instruction is add 3 to that value. And then the next instruction is store the result of that at address 12, for example. So that's kind of an example of some basic instructions in computer science. Now, what we want to do is look for this string. This is the address of the next instruction in this column. Okay, and if we find it, we're going to return whatever's in column 1. And if we don't find it, we'll probably return null. Okay, so I'm just going to do a linear search. I'll tell you what, let's do a linear search. And I'm just going to use a for loop to do this. Could use a while loop. Now remember, ram.length tells me how many rows there are. So I'm just going to work my way through each row, and I'm going to visit the first column. So if ram at row I, column 0, if that string is the same as this S, if they're the same, it means I found the address in RAM. So we're going to return whatever's at the next column. Okay, so that's what my for loop's going to do. And if I finish the for loop and I didn't return anything, it means I didn't find the address, so I'm going to return null. So that's my visit RAM function complete. I've got an error here. What's that error? Oh, it's just a naming error. Okay, so visit RAM's fine. Now the control unit is, I'm just going to make it super simple. It doesn't return anything. What do I call it? Control unit. And it does take a parameter. There's one parameter. There it is. What is that data type? Let's just work our way up through the program. There it is. Keep going. You'll find it eventually. There it is. We've declared it as a string. So we're sending a string to the control unit. Call it what you want. It's just a parameter. Could be X. Doesn't matter. Ooh, I'll tell you what. Okay, we'll come back to that in a minute. What the control unit does is say, just very basic, current instruction being decoded, and we'll just say whatever is in X. That's all it does. We'll keep it very simple. But I do need to think about something here. If the MDR, if we get null back, we don't want to call the control unit. Okay, so if MDR doesn't equal null, we'll do this. Else, we'll just put a message. Possible error, whatever, it doesn't matter. Okay. Right, so we've done that, and now let's just create a very basic ALU function. Super basic. We can make it more complicated later. System.out.println. Executing in ALU. Now actually we only want to execute if we've decoded, so we need to put that after the control unit. We can only, okay, so does that make sense? So let's run the program and see if it works. Whoa!